Silva here. So thanks for joining, and we are going to discuss about an interesting topic, that is shall we use transformer which is designed at 50 hertz? Shall we use the transformer in 60 hertz and vice versa? So probably means we may aware. Means what to say, we have different rated frequencies. There are across the world. One is 50 hertz and 60 hertz. These are predominant. Apart from that, there are other frequencies also in use, like 400 hertz or 16.7 hertz. Depends upon the location to location. Fine. So now question is, if the transformer is designed for one particular frequency, shall we use that transformer for another different frequency? Right. So means if we changing the transformer, then what are the parameters will change and how it will impact, that's what we are going to talk about. Okay. So means what you say, probably you might have seen some small dry type transformers used for an electronic circuit or something, stepping down the voltage from 230 volt to 12 volt or 24 volt. That is rated for both 50 hertz and 60 hertz. That means the transformer can be used at both 50 hertz and 60 hertz. If so the case, why not the large power transformers of like 100 MVA or 50 MVA or 2 MVA transformers, which can be rated for dual frequencies. So let's try to answer the questions one by one, and if you have any questions or answers, probably feel free to means put it in a chat box. Meantime, I will open the ETAP as well. Right, done. Okay. Fine. So let the ETAP get opens, but means what to say, anyway, we are not going to much discuss about ETAP. So means we will be specifically addressing the question of this transformer, right? So let's have a just look. Okay. Means we know the equation which defines what's the voltage induced in the transformers, or what is the voltage equation which relates the transformer with respect to the flux, frequency, form factor, etc., etc., right? So if you write the voltage equation E or V in a transformer, that relates like 4.44 F pi into T, right? So you may aware of that equation, and you also know why V by F has to be maintained in all electrical equipments, right? Why you have V by F relay or overfluxing relay in a transformers, right? So means with respect to this, we will discuss bit more, and we will also see impact of this transformer which is designed at one, how it behaves with respect to the other frequency, right? Done. See, now assume that the transformer is manufactured at 50 hertz, and if you are using that at 60 hertz, what will happen? What will be the impact on the transformer impedance? More specifically, the transformer reactance. The transformer reactance will increase by 20%, because as we know, XL is 2 pi FL. So if we manufacture the transformer at 50 hertz, and if we tend to use that at 60 hertz, yeah, probably I am just taking some small example of transformers, means forgetting everything. Yeah. So yeah, I have taken a 2 MVA transformer. The system frequency is 50 hertz. See, the frequency is 50 hertz. So the transformer is now designed at 50 hertz. So probably you can see the transformer rating is 2 MVA, and the transformer impedance is 6%. If the same transformer is used at 60 hertz, what will be the impact? Obviously, means this percentage X, the reactance value will increase, because we know XL is equal to 2 pi FL, L inductance remains constant, and X will increase. And 50 to 60 hertz, it is 20% change in frequency. So similarly, this reactance also will change by 20%. That means approximately your impedance will jump from 6% to 7.2%. X and R will not change in the same proportion, right? So let's address that question also. Yes, question number 1. Do you think that the resistance will change with respect to the frequency? Yeah, probably if you know that answer, I mean here we have two terminologies. One is percentage Z, that is the impedance of the transformer, that is further classified into reactance and resistance. If we have designed this transformer at 50 Hertz and if we are trying to use at 60 Hertz, what will happen on percentage X and what happens on percentage R? X, we have a straightforward equation, correct? XL equal to 2 pi FL. So if the frequency increases by 20%, this percentage X also will increase by 20%. But what happened to the resistance? Resistance, is it a function of frequency? Yeah, many of you may say no, but the frequency also has an impact on the resistance, right? Let's take a circular conductor, apply a DC voltage. The current flowing through the conductor, which is a DC current, is uniform. That means the current density flowing through the conductor is uniform across the conductor. Whereas if we apply a voltage, that is an alternating voltage, AC voltage, and the current distribution in the conductor is not uniform. Thanks to skin effect, the current which concentrate more on the outer surface, correct? No, the tendency of the alternating current to concentrate on the outer surface is skin effect. So means if you apply an AC voltage, when the current flows in a AC current flows in a conductor, the current flow is not uniform across the conductor. Current tend to concentrate more on the outer surface and less on the center. So when the current is flowing higher at the outer surface and lesser at the center, then the losses which has been created in both AC line and DC line for the same current flow will not remain same. The current is not uniformly flowing. So probably because of this, there will be an increased losses in the AC network. I am not talking about the reactance or capacitance, I am purely talking about the resistance. So if you look at some cable manufacturers, they specify RDC at 20 degree or something. When you convert that into RAC, you need a constant K which needs to be multiplied. That depends upon the frequency, which is 50 Hertz or 60 Hertz, or the severity of the skin effect increases with an increase in frequency. So percentage R also will change, but how much percentage will change will not be just given by a simple straightforward equation like XL equal to 2 pi FL. So my point is the 6% impedance will change to a new value if this 50 Hertz designed transformer at 6% impedance used at 60 Hertz. So this percentage X will change from 5.918 to a new value which is 5.918 into 1.2. But what about this percentage R which is 0.986? That we do not know. So that probably there are some constants which probably 1.3 or 1.6 depends. So that has to be multiplied by that number. So you will get a new percentage Z. So if we have the same transformer, 2 MVA transformer, 11 bar 415 volt, which is designed at 50 Hertz, and if we are using at 60 Hertz, the impedance will change. Impedance will increase. If the impedance increases, what will happen? Because of the increase in reactance, the reactive power loss will be more, that is precisely 20% more, and real power loss also will be more, that is proportional to what is the increase in resistance. The voltage drop will be more, but this will reduce the short circuit current. So, but still you will be able to use this transformer which is designed at 50 Hertz to 60 Hertz without any technical problems, except this increases the real and reactive power losses, increase the voltage profile, but it has an advantage of reducing the short circuit current. With this, you will be able to technically run this 50 Hertz designed transformer at 60 Hertz. But question now, I mean, shall we use vice versa? The transformer which is designed at 60 Hertz, shall we use at 50 Hertz with reduced real power loss, with reduced reactive power loss, and probably with an increased short circuit current? Answer is no. So going back to my equation, voltage equation in, let me find out some equations. I have not prepared the slides anyway, so quickly get some equations. Right, induced voltage equation. Yep. Let's try to get some equations. Yes. So you have some equations, right? There's a C2 by E1, but anyway, means what do you say? You will get almost similar equations. E is 4.44 Fn by m, right? So the voltage can be, means you can write using this equation, E1 equal to 4.44, that is 4 into 1.1, that is 1.1 is the form factor, F is the frequency, N1 is the number of terms, and phi is the flux. Right. Now, means induced voltage is important. That voltage is fixed because we have designed this transformer as 11 bar 415 volt and we have designed at 60 hertz. So coming back to this equation, means what say E is fixed, that is either 11 kV or 415 volt. 4.44 is fixed, number of turns is fixed, and F, that is originally designed for 60 hertz, but now we are trying to use it at 60 hertz. Sorry, originally it is designed for 60 hertz, now we are trying to use it at 50 hertz. So if you take this equation and bring this F to this left hand side of this equation, E1 by F, that is proportional to pi. Since the designed frequency is 60 hertz and the operating frequency is 60 hertz, means other side the flux pi m will increase, right? Sorry, I think I'm going to another equations, but anyway, so the equation, if you bring this F to the left hand side, then means what is a V by F or E by F is proportional to pi. So if you tend to operate the transformer which is designed at 60 hertz and if you are trying to utilize at 50 hertz, then the flux will be means what to say will be higher. So that's basically what we are talking about, the overfluxing relay. V by F means in all the equipments we need to maintain the V by F constant. So you cannot use a 60 hertz transformer which is designed at 60 hertz at 50 hertz, right? If you want to use that, you can probably proportionately reduce that voltage. That means you have to reduce the V by F. Sorry, you have to reduce the V so that V by F is constant in this equation. That means if you have this transformer 11 bar 415 volt 2 MVA transformer at 60 hertz, and if you want to use this at 50 hertz, then this transformer can be used with a reduced voltage which is 11 into 50 bar 60. That's the new value which will come, right? So let me take an Excel sheet as well. So if you want to still utilize this transformer, at max what you can do is you can use it at 11 into 50 divided by 60, that is your, so 9.16 kV on the HV side and 0.415 into 50 divided by 60, that is 345 volt, 0.345 kV on the low voltage side is what you can operate. So means at this value only your V by F is maintained constant. So if you want to use the 11 bar 415 volt transformer which is designed at 60 hertz and if you are trying to utilize it at 50 hertz, you can use at a reduced voltage of 9.16 kV slash 0.345 kV. If you use 11 bar 0.45 kV transformer which is designed at 60 hertz and if you are trying to use at 50 hertz, then it will result in overfluxing and probably the transformer get damaged. So let's quickly go to the what Snyder talks about, the same thing. Okay, can a 60 hertz transformer be energized at 50 hertz source? Answer is no. So what's the resolution which they are giving? I think it is visible, and even I think the link is also visible. I can post it in as a part of description. A 60 hertz rated transformer can only be used on a 60 hertz system with certain exceptions, yes, of course. Whereas 50 hertz transformer or 50/60 hertz transformer, that 50/60 hertz generally you can see it in a small transformers which are 230 volt bar 12 volt or 230 volt bar 24 volt transformers, that can be used in both the 50 hertz and 60 hertz. So as I told, if you are using this 50 hertz transformer in 60 hertz, then you will be having an increased losses, increased voltage drop and with reduced short circuit current, but you can use at least technically. Whereas the 60 hertz transformer cannot be used at 50 hertz. Then they have given some exception. What is that exception? Yes, if the energizing voltage is reduced to 83%, what is that 83%? That is 50 bar 60. If you divide 50 bar 60, sorry, that is 0.833. So means if you reduce this voltage at both the sides to 83%, then you can use this 60 Hertz transformer at 50 Hertz, but it can be used only with the reduction in the voltage. This transformer can be used. Remember that transformers are simple ratio devices and the output will also be lower, of course. I mean, if it is not on the one side, it's on the both side. Another important factor to remember that the transformer capacity will also have to be derated at the same ratio of the applied voltage, of course. That means if you are applying, so let's conclude this. If I have designed a transformer at 50 Hertz and if I am trying to use the transformer at 60 Hertz, what will be the impact? I can use it with the same capacity, but there will be drawbacks of increased real power loss, increased reactive power loss, increased voltage drop, and it has an advantage of reduction in the short circuit current on the low voltage side. But if I am trying to if I am trying to use a transformer which is designed at 60 Hertz and if I am trying to use at 50 Hertz, you cannot use it. If you want to use it, you have to reduce the voltage to 83.33% on the both the sides and you can utilize it. And this also will have an impact on your rating. That means the 2 MVA transformer of 60 Hertz, if you want to use it at 50 Hertz, the rating also has to be derated to 1.66 MVA. So I think that's clear. If you want to use 11 bar 415 volt transformer, 11 bar 0.415 kV transformer, which is designed at 60 Hertz. If you are trying to use it at 50 Hertz, then you can use it as a transformer of only 9.16 kV bar 0.345 kV. And you can use it at 50 Hertz, but the transformer rating will no longer be 2 MVA, that is only 1.666 MVA. I think that clarifies most of your doubts. So here again, let me go back to the Snyder material. Yeah, they have given two important aspects. One is 50 Hertz transformer or 50 Hertz or a 60 Hertz, means you might have seen some transformers of electronic transformers of 230 volt but 12 volt or 230 volt but 24 volt, that might be dual frequency, because at that smaller capacity, huge in numbers, there is no advantage of going for two transformers. One is rated at 50 Hertz and 60 Hertz, so that is the dual frequency rated transformers. But normal power transformers at 50 Hertz can be used at 60 Hertz with increased real and reactive power loss with increased voltage drop. But vice versa is not true. That means 60 Hertz designed transformer cannot be used at 50 Hertz. If you still try to use it, you can use it at a reduced 83% of the voltage as well as at a reduced rating of 83%. Right. Hope that's probably clear. Any doubts on it? So probably we can discuss. You just text it and we will be taking up the questions in the upcoming sessions. Right? Thank you. Have a nice day.